So, hello, I'm Jonas, CEO and co-founder of Okapi Orbits, and our mission is to become the backbone of safe space operations. So, we start with the problem. Consider space, and as the name already suggests, you think, okay, space, it's a full of nothing. But I think most of you know this is actually not the case for the orbits around our home planet. When we look there, currently about 900,000 objects larger than 1 centimeter are all endangering active missions, not considering the impact on the environment if one of the larger satellites would actually collide. And of course there are already measures in place which in parts mitigate these risks, but all of them are based on really complex, heavy processes which rely on US military data to estimate the outcome of a situation that is rather okayly described. And they furthermore include a lot of manual work, a lot of meetings, you have telephone calls, emails, etc. pp. So when you're looking on applying these processes to actually new space companies, you get to costs for the collision avoidance that is getting unreasonable to the problem that you're actually trying to solve. And what we're working on is an AI-powered platform to provide space situation awareness as a service. And with this platform, we're not focusing only on satellite operators, but on all space actors. So we are also creating services for ground station operators, people who have their sensors and want to process their data, or legislators who want to know what's happening in space. But I will focus here on the collision avoidance. So how does it work? Well, we have first the data collection. And here, maybe it's important to note, we don't create our own data, we focus on the processing. So we are sourcing all data that's available out there. Currently, our primary source are conjunction warnings that are issued by SpaceTrack or USTRATCOM, however you call them. We fuse the data with the operator's own data, and we have a network of partners who can give us tracking data in case of very critical events. All this then goes in our platform. I show on the next slide some more detail about how this works. And we process the data into an actionable result that we deliver to the customer, who can access this via programming interfaces, so you can directly use it within your operations. Alternatively, we also have web interfaces, but the focus is really on the APIs in the moment. So how does our backend work, or our magic? It's basically a stream processing system, which means we have on the one hand side the data sources which provide a continuous income of the data. And in our stream processing backend, we have different types of so-called operators. They're actually, I think, very similar to the boxes or blocks that Latitude 40 explained before. And each of them provides a different functionality. And there we have two types of functionality. First, scientific functions, which help us solving physical problems like orbit propagation, orbit determination, path prediction, conjunction analysis, and similar things. So it's some kind of flight dynamic software. And on the other side, we have intelligence operators, which helps us with fusing the data, so deciding which data do we use in what situation, and also the decision making. And there, for example, we are currently preparing a patent for one process that helps us deciding in a conjunction event already 5 days in advance if this conjunction will get critical or not. Yes, and the nice thing is you can combine them always to the case you're having in the moment to give exactly the result to the customer he needs to solve his problem. And the USPs we offer. Using our platform, you always have all your algorithms and data in one place ready to use, so you don't have to go around the world and pick the tools you need to fulfill the task. It's all there. We furthermore apply data intelligence and AI to gain better data insights. And this brings us also to the next point. We enable earlier maneuver decisions in case of a conjunction, which reduces the costs. And we focus on machine-to-machine interfaces, which allow full automation on the side of the customer. Our team, we're 4 founders. Christopher, Sven and myself have worked in research on SSA and space debris related topics for the last 7 years at the Technische Universität Braunschweig. Some might know them, they are very prominent in the field of space debris modeling. And we completed our team with Christina, who is helping us scientists basically to create a business out of our scientific ideas. And if you find interesting what we're doing, I would be happy to talk to you either here today, or you can also contact me by email on the website. So thank you.
Hi, maybe you can comment on who is your customer and what is customer profile and who is going to bring the money?
Yes, for the collision avoidance service, basically, we target mostly small to medium-sized constellations, because for them the issue of handling conjunction warnings and collision probability is higher than single satellite missions, and they would also pay for this service. For the other services, again, we also look at ground stations, legislators, space agencies, and similar.
How developed is your actual platform? Are you already selling to customers? What sort of stage is it developed?
Yeah, we currently have a prototype of the platform online and running. And we're doing some iterations in the backend at the moment to increase a greater scalability. And the release of the platform, as shown there, is planned for end of the second quarter of this year. And with the platform, we have no customers yet. We have users. So basically, we use our prototype to gain feedback on the usability and the reasonability of the approach that we are planning to do.
Who are your competitors and how do you compare to them?
Yes, we have competitors. Most of them are US-based. And well, what we do different first is that we have an API-based, cloud-based approach. So with using our services, you don't need another software. You can just use your own operation software and include some lines of code to fully use our services. We are the first starting really focusing on providing AI services. And in contrast to most of our, especially European competitors, we really don't rely on single data sources, but look in all spaces where we can get the data that helps us in this situation. If you want to hear company names, I would think the most similar service is provided by SpaceNav in the US. They also provide some kind of web interface for conjunction warning analysis more than actionable results. And when we look to Europe, it's the space agencies themselves who offer some services, and companies like GMV, for example, who have some related services integrated into their operation software, for example.